Hey class, today we learn about inequalities. So our aim for the day is that Kipsters will be able to write and solve inequalities. Let's get started with key point 1, a real world example. So in our example, Tariq is trying to save $265.49 to buy a new tablet. Right now, he has $40 and can save $38 a week. So $38 per week, or we could say $38 each week from his allowance. Write and evaluate an expression to represent the amount of money saved after 5 weeks and after 6 weeks. So after 5 weeks, we could say that he has saved $40 because he starts with $40. It says he has that right now, plus the amount he saves each week, which is $38, and we're going to multiply that by 5 because he's saving for 5 weeks. So this gives us 40 plus 190, which equals 230. Now I can compare this 230 with the amount that he needs to save. So we say 230 and then leave some space. And let's write $265.49. That's the amount he wants to save. So we're going to put our inequality symbol here, but I want to remember which way it should face. I know that 230 is less than 265.49. So I'm going to write less than just to remind myself what this symbol looks like. Which way does it face? Well, the alligator eats the bigger number, so it's going to face that way. I know it's silly, but it'll help you remember. So $230 is less than $265.49. So Tariq needs to keep saving. What I want you to do now is go ahead and solve for how much money Tariq will have saved after 6 weeks. Awesome. So you should have something like this. He starts out with $40, plus he saves $38 per week for 6 weeks. That gives us 40 plus 38 times 6 is 228 for a total of $268. And now we can compare that with how much he needs. So 268, let's compare it with 265 and 49 hundredths. So in this case, it's not less than, this is greater than, so 268 is greater than 265 and 49 hundredths. So now the alligator eats the bigger number, and we actually have the answer to the next question. When will Tariq have enough money to buy the tablet? He will have enough money after 6 weeks. Last part. Let's go ahead and write an inequality that will generalize the problem. So for any number of weeks, he's going to have saved $40 because he starts with that amount, plus he's saving how much per week? Good, $38 per week. And to generalize, we can just use a variable. I'm going to use W as the number of weeks. So W is our number of weeks. And I know that this is the amount he saved, and we want to know when will that be either greater than or equal to the amount he needs. And the amount he needs is $265.49. Good, let's go to the next page. Let's scroll down here. So next we're going to go through number 2. It's another real world example. It says, Connor went to the county fair with $22.50 in his pocket, and he bought a hot dog and a drink for $3.75, and then wanted to spend the rest of his money on ride tickets, which cost $1.25 each. Write an inequality to represent the total spent, where R is the number of tickets purchased. So thinking about what we did on the front page, I want you to go ahead and try to write an inequality for part 2A. Go ahead and do that now. Great, so you should have something like this. We know that he's going to spend $3.75 on the hot dog and the drink, and he's also going to spend an additional $1.25 for every ride ticket, so we can multiply that by R. And then over here on the right side, I know that he only has $22.50 to spend. That's all the money in his pocket. So, I changed the pen size here, sorry. He has $22.50. So I know that the amount he spends, it has to be less than or potentially equal to the amount he has. So that's our inequality. Part B, what is the total maximum number of tickets he can buy based on the given information? So what we're going to do here is solve our inequality. So $3.75, I'm just going to rewrite it as it is above, plus $1.25 times R is less than or equal to $22.50. So we need to isolate our variable. I'm going to subtract $3.75 from the left side, and I need to do that to the right side also. This gives us, let's see, on the left side we're going to have $1.25 times R is less than or equal to $22.50 minus $3.75 is $18.75. One more step, we need to divide by $1.25 on the left to get R by itself. And if we do that to one side, again, we do that to the other. Divide by $1.25. And if you do the math here, that'll give you 1R, or just R, is less than or equal to 15. So what that means is 15 is the maximum number of tickets that Connor can buy. Let's look at number 3. So I'm going to scroll up a bit so we can see this. Okay. On a particular airline, checked bags can weigh no more than 50 pounds. Sally packed 32 pounds of clothes and 5 identical gifts in a suitcase that weighs 8 pounds. Here's your first chance to practice. So write an inequality to represent the situation. Thinking about what we did on the left, go ahead and write your inequality now. Great, so you should have something like this. We know that Sally packed 32 pounds of clothes plus 5 gifts. We don't know how much the gifts weigh, so I'm going to put 5 times a variable. I'll use X. Plus the suitcase already weighed 8 pounds. So this is the amount the luggage weighs. And we know that it has to be less than or equal to the maximum that the airline allows, which is 50 pounds. So this is our inequality. Here's another chance to practice. Go ahead and solve this inequality for X. Awesome. So let's see. We have 32 plus 5x plus 8. And this is less than or equal to 50. I want to solve for x. First, combine like terms on the left side. 32 plus 8, that gives us 40. We still have 5 x's. And it's all less than or equal to 50. Okay, let's solve for x. Take away 40 from the left side. If we do it to the left, we do it to the right. So now we have 40 minus 40 is 0. I have 5 x's on the left side. It's going to be less than or equal to 50 minus 40, so that's 10. One more step. I have 5 x's, so I can divide by 5 on the left. If I do it to the left, I do it to the right. Divide by 5, and here we get, sorry, let me draw a dividing line. Here we have x is either less than or equal to 10 divided by 5, which is 2. So now we know that the most the gift can weigh, the 5 gifts, the most one gift can weigh is 2 pounds Otherwise, Sally is going to have to pay extra money to check those bags for her flight.